Good morning, everyone. Myself Videsh Kem and my teammates are Vachanasiri, Aditi, and Sneha Vaivi. And today our topic is about IPL T20. I am going to engage about the problem statement. In this, the Indian Premium League is one of the most dynamic and data-rich sporting events in the world, involving complex interactions between players, teams, matches, stadiums, and action mechanisms. Managing all of this information manually or through scattered fields can lead to inefficiencies, data loss, and lack of proper analysis. Here, the core problem is to design a centralized relational database system that can store, manage, and retrieve all information related to IPL tournaments in an efficient, scalable, and accurate manner. In player management, Indian and international players participate. Each player is part of different team across seasons. We need to track performance like runs, wickets, dot balls, etc. For player is each match. Team management. Each team has an owner, coach, and set of players. Teams change every season depending on actions and trades. Teams plays multiple matches each season. In action system, before every season, an action is held where players are brought by teams at varying prices. The database must track which player was sold to which team, in which year and at what price. By coming to the fourth point, match scheduling and results. In this, each match is played between two teams on a specific date in a specific stadium. The database must record matches details like date, team involvement, stadium, and winner. In stadium management, matches are played at different stadiums with varying capacities and location. The database must allow assigning matches to stadium. By coming to the performance tracking, for every match, we must store how each player performed, total runs, wickets taken, dot balls delivered, etc. In reporting and analysis, users like admins, coaches, fans need to generate insights like top run scores. In this, most expensive players brought in actions. In stadium wise and match coach, player wise season performance summary. So, in this, what's the challenge is all of this data is deeply interconnected. A player plays for a team in a match held at a stadium as a performance. The same player might be ac- considered to another level. Thank you so much. And the next further part will be continued by Aditi.
This talk, madam. Start, madam.
Mm.
Thank you, Vidyashri. Myself, Aditi. Now I'm going to explain the ER diagram part and the relational data scheme. Certainly, let's explore the ER diagram. The ER diagram is entity relationship diagram, is a visual representation of the entities, tables, their attributes, and relationships among them in a database. Here's the breakdown of the core components. First, entity. Player attributes. For the entity player, attributes are player ID, player name, and country. Represents each player, whether they are Indian or international, who can be a part of team and participate in matches. Second entity is team, and its attributes are team ID, team name, owner, coach, and country. Description is stores information about teams playing in the IPL match. The third entity is match. Its attributes are match ID, date, team 1, team 2, and the result. Contains details about each match played between two teams. Fourth entity is stadium. The attributes are stadium ID, name, location, and capacity. Where the match is hosted, each match is held in one of the stadium. Fifth entity is auction. The attributes are auction ID, player ID, team ID, match ID, or season ID, depending on the structure, and price. Description is records the sale or bidding price of a player to the team during action. The sixth entity is performance. Its attributes are performance ID, player ID, match ID, runs, wickets, and dot balls. The description is tracks how a player performed in a specific match. The relationship between the entities and their attributes are player plays in match, many to many function. Player plays in match, one to many function, team 1 and team 2. Match held at stadium, many to one function. Player sold to team via auction, many to many function. Player has performance for match, many to many function. We use relationships and foreign keys to connect these entities. Now for the relational schema. The relation schema is a tabular form of the ER diagram that shows how entities and their attributes translate into tables. Here's the relational schema for the above ER model. Player ID is the primary key, player name and the country. Team ID is the primary key. Team name, owner, coach, and country are the attributes. Stadium ID is the primary key. Name, location, and capacity are the attributes. In match ID is the primary key. Date, team 1 is the foreign key. Team 2 is another foreign key. Result, stadium ID is also a foreign key. Auction ID is the primary key. Player ID, team ID, match ID or season ID, and price are the foreign keys. Performance ID is the primary key. Player ID, match ID, runs, wickets, dot balls are the foreign key. Primary keys are uniquely identified each row in a table. Foreign keys establish relationship between the tables. Team 1 and Team 2 in match refer to team ID in team table. Player ID in performance refers to player tables. Stadium ID in match refers to stadium table. Many to many relationship, for example, player via match performance are broken down using junction tables. Summary of relationship in schema form. One player can have many performances. One match can have many performances. One team can participate in many matches. One player can be auctioned to different teams for different matches or season. One stadium can host many matches. This ER diagram and schema ensure data is normalized, no redundancy is taken, integrity is maintained using primary and foreign keys. You can perform efficient queries, for example, top run scores, team stats, match, and summaries. Thank you. The next part will be continued by Vachana Siri.
Thank you, Aditi. I'm going to explain about the SQL query. In the first query, we'll get the names of the top 5 players who have scored the most total runs. In this, it helps us to identify the most valuable batsmen of the tournament. Coaches and fans can use this to evaluate batting form. Could be used to detect the orange cap, which is highest score runs. In the second query, it helps us to retrieve the list of the players who have appeared in the match with ID 101. It helps us to give the team lineup for the particular match, can help replay or analyze the past match performance. In the third query, it shows which match was held in the which stadium at and when. It helps us to provide the insight into the venue usage, can be used to generate, schedule, or assign stadiums. Useful for the organization managing logistic, example, seating, lighting, etc. In the fourth query, it helps us to list out how many players each team has bought in the action. It is useful for ensures that the team squad sizes are within limits. Example, maximum 25 players. Allows analyze of a team strength and squad depth. In fifth query, it helps us to know the least players. It helps us to list the players who have taken the highest number of wickets in the tournament. It is used helps to find the best bowlers in the league. Can be used to avoid purple cap, which is the most wickets taken. In the sixth query, it helps us to calculate the average number of runs scored by a particular player. It helps us in analyzing the player consistency, can compare the average across the different season or the opponents. In seventh query, it helps us to list all the matches played by a specific team. It helps us to track the full season's history of a team, useful for the broadcast and analytics preparing content. In eighth query, to get the top 5 most expensive players bought during action. It helps us to evaluate financial decision of a teams, could be used in the reports on action spending patterns. In ninth query, to calculate the total runs scored by all the players in the team,
Team performance tracker compares batting power across different teams. In 10th query, get matches list where stadium name vacant stadium. It helps us to know the stadium management, understand footfall, useful for marketing, logistic, and maintaining analysis. The summary is demonstrate the real-time process reporting of a Power SQL, allows fan coaches, organization, and analytics to exact the key status. And the next part will be continued by Sneha. Thank you.
ಮಾಡ್ಲೇನೆ ಸರಿ Thank you, Siri. Now I am explaining the conclusion part. In this IPL T20 DBMS, we successfully designed. ವಿದ್ಯೆ ಮಾಡು. Thank you, Siri. Now I am explaining the conclusion part. We successfully designed and implemented a database system to manage and organize the information related to the Indian Premier League. The project involved storing and retrieving data such as team details, players, matches, scores, venues, and results efficiently. By using the database concepts like tables, primary and foreign keys, normalization, and SQL queries, we demonstrated how a large sports tournament like IPL can be managed digitally with accuracy and speed. This project improved our understanding of how real world data is structured and handled using DBMS and how queries can be used to gain insights. Overall, this project highlights the importance of databases in sports management and helps in making data driven decision effectively. Thank you.